Welcome to Hardwood Home Lab, everybody. Today I'm going to be installing Pi-hole once again, but this time I'm going to be using Unbound and DNSproxy for end-to-end encryption. If you're interested in seeing how I do this, then come check it out. So I made this diagram to kind of visually show what I'm setting up here today. The idea is that if I've got a client within my home network, it can use DNS over HTTPS, DNS over TLS, or DNS over QUIC to make a DNS request of DNSproxy. Then DNSproxy will forward that DNS request to Pi-hole, and Pi-hole will use its filtering rules to decide whether to allow or deny that DNS request. Pi-hole will then forward that DNS request to Unbound, and Unbound will use DNS over TLS for an encrypted TLS DNS request to a Quad 9 DNS server. So with this setup, there will be end-to-end encryption from the client all the way back to Quad 9. Now, this encryption layer inside your home network is maybe not entirely practical. It could be useful if you've got a client within your home network that expects to use one of these encryption protocols, but within your home network, you're only really hiding your DNS requests from yourself. I've also got port 53 open to Pi-hole, since that allows me to use Pi-hole the same as I did before I introduced DNSproxy, because DNSproxy kind of breaks some of the features of Pi-hole, which I'll show you in a bit. Realistically, the biggest reason you might want to use DNSproxy is for this scenario here, which I've drawn in the diagram, and that's if you want to use your DNS server from outside of your home. For this scenario, this being your firewall, you would need to have a port forwarding rule for port 443 and port 853 so that traffic could get from outside of your network into your DNSproxy. In this video, I'm not going to be covering how to expose your DNS server outside of your home network, since there's a whole lot of variables that could be different depending on how you got your domain and what DNS provider you're using, what firewall you're using. So if you want to set that up, you're going to have to Google how to do port forwarding on your router and how to do dynamic DNS. And if you're wondering, why would I need to use dynamic DNS to use my DNS server? That's because with these three protocols, they're all accessed by a domain. So if your end client is using any one of these protocols, they're going to have to bootstrap off of a traditional DNS server first. With all that being said, let's get into installing this. So on my terminal, I'm SSH'd into a fresh install of Debian. All I've done is cloned my Debian template, which if you're curious on how I set that up, I've got a video for that. I'll try and put a card here in case you're interested. But the only other thing I've done is set up a DHCP reservation so that when this virtual machine boots up, I get the same IP every time. So with that static IP mapping set, I'm ready to install. I'm going to start with Unbound and work my way back to DNSproxy. So in order to install that, I'll run sudo apt update and sudo apt install Unbound. On Debian, when you install Unbound, it typically starts it up automatically, so I'm just going to take a look at that and see if that's the case. And yeah, right here you can see that it's active and running. I don't really want Unbound running while I'm setting the configuration files, so I'm just going to shut it down for a bit. So I'm going to run sudo systemctl stop unbound.service. Now if I check the status, it should be inactive, and it is. Now we're going to have to create a configuration file that's going to tell Unbound the state that we want it in. With that, I'm going to use vim at etc unbound.conf.d, and in here I'm going to create a file called piehole.conf. Now the contents for this file I've just pulled directly off of the Pi-hole documentation site. So I'll just switch to my browser, and down here I'll scroll to where they've got this file listed here. I will copy that and paste that configuration in here. And in here there's a few more lines that we're going to have to add if we want to have that backend TLS encryption. And those lines, I'm just going to copy them from my notes and paste them in here. And I just kind of want to clean the look of this up a bit. I think I've spent too much time using YAML files. So these last few lines we've added in here define that we want to use TLS encryption upstream. It needs an SSL certificate in order to establish that encrypted connection. But on this end from Unbound, it doesn't need to be a signed certificate. And down here, I'm defining that I want to use the Quad 9 servers on port 853. So that's all we need in this config file. I'm going to write and quit that. And now I should be able to start the Unbound service again. I'll check on the status, and it looks like it is active and running. With Unbound configured and running, we can install Pi-hole, and I'll just use their install script. Now on the install script, when you get to this point that says select your upstream DNS provider, I'm going to set this to use the Unbound resolver that I had just installed. Right here is actually the address we want to put in. So this is what it should look like. So the rest of the settings I just left as default, and once the installer is done, you'll want to take note of this password that it gives you if you don't want to change it yourself. I'm going to just change this from the command line, so I'll click OK, and in here you write Pi-hole, I think it was password? Oh, sorry, set password. And you need root for that. And I'll just change this to a super secure password. So I'm also going to be changing some config files for Pi-hole, so I'm going to shut that one down just the same as I did for Unbound. And the config file that I want to change is etc Pi-hole piehole.toml. In here, our upstream DNS server was configured properly. Since Pi-hole is using port 443 and port 80 for the web interface, and we need to use port 443 for DNS over HTTPS on the DNSproxy, we're going to want to disable listening on 443 in Pi-hole's config here. So I'm just going to search for 443, and you can see it's just down here, this line with port. And then you're going to want to delete this section that says 443 OS and 443 OS on IPv6. If you don't have IPv6 in your home lab, you probably can delete everything from this colon over to the right. But I'm going to leave the IPv6 settings in here, so I'm just going to remove that, and then that. So now this is going to leave only port 80 on IPv4 and IPv6. So with those changes, I can write and quit, and we can restart the Pi-hole service. If I can spell sudo. I just want to make sure it's running, and that looks good. Now at this point, Pi-hole is installed, it's configured to use Unbound, and it's totally usable as a DNS server. Everything from this point on is just to provide encryption in front of Pi-hole. Now I'm going to use a program called Lego to grab a signed TLS certificate from Let's Encrypt for that encryption, and the documentation for that recommends that we install that using snap. So I'm going to have to install the snapd package. So to do that, I'll run sudo apt install snapd, and then I'm going to use snap to install Lego. Now with Lego installed, we can use it to grab a TLS certificate. If you're like me and you're using Cloudflare, this is the command you're going to want to run. You'll want to change your email on this line to whatever email you used to sign into Cloudflare. You'll need to create an API token and paste that here. Here, you'll want to change to the email that you're using for Let's Encrypt. And here, you'll want to change the domain that you're using for your DNS server, and here the domain zone. So for my example, I would put hardwoodhomelab.demo.xyz here, and here I'm using dns.hardwoodhomelab.demo.xyz. So I'm going to fill in the rest of my information for these things. I'm going to run that command and then I will be right back. So I ran that command. I had to agree to the terms of service, and you can see I've got a certificate now. I'm going to get a little bit deeper into some Linuxy stuff right now so that I can automate the renewal of this TLS certificate. You don't have to do this if you're uncomfortable with it. You can just run this command that I showed earlier again, but if you change run to renew here on the back end, it will reach out and renew that certificate again. And you can do this manually. But I find that tedious, and you have to remember to do it every 3 months. I don't want to do that, so I'm going to automate this. To automate that, I'm going to create a script, and I'll just call this one renew. And in here I'm going to paste essentially the same command that I just showed you. The only real difference on this from the command that I showed on the terminal is at the top we've got this shebang for the script, and there's no sudo on here because this script is going to be run by root. So off camera, I'm going to put in my personal details here just the same as before, and I'll save it and I'll be right back. Now that I've got my script saved, it's got some sensitive information in there, so I want to protect this, and I'm going to do that by changing the ownership to root. So I'll use sudo chown root renew.shell, and then I want to change the permissives so that no one other than root can read this. And I personally like to keep my shell scripts in the user local bin directory, so I'm going to move that there. With that renew script in this directory, that puts it in the path. So if I look up which renew.sh, oh, I forgot to make it executable. So I'm going to have to run sudo chmod +x user local bin renew.shell. Now, if I look for that in the path, there it is. Now that my renew script has the right permissions, it's in the location I want, I'm going to want to create a systemd service for it so that I can use a systemd timer to automatically run this script. And this command will do that. I'm running systemctl edit. Force is going to create a new service file. Full means it's going to be a full service file, and this is the name of the service file it's going to create. I've created my service file off camera so that you don't have to watch me stumble through with all my typos. And it's very simple. I've just got a description here. You can have anything you want in here. I just called it Renew DNS Encryption Certificate. After, so we want to make sure that the network is running. And then under the service section, it's a type one shot. So that just means that it's going to run that program, and when it turns off, it's not going to try and restart it. And then exec start is just the binary that it's going to run. So it's going to just run that shell script when this service gets activated. So I'm just going to write and quit. And then to have systemd start this script for us, I'm going to have a timer. This is basically the exact same command, only instead of .service, it says .timer. And it's important that the names of these match, because this timer will automatically look for a service file that has the same name. So make sure that those are identical. And then I'll paste this into the timer file. So what I've pasted in here under the unit section is just a description that you can have whatever you want, anything after the equals sign. The real important stuff on this file is actually under the timer section, where it says this on calendar line. What it's going to do is run that service file that we just created on the first day of every other month at 3 in the morning. The persistent line underneath that means that if it misses its target right here, it's going to run it at its earliest opportunity. And the randomized delay sec means that it can start any time within an hour of this target. And then the install section, I'm not really going to get into what targets are on Linux. Just leave it at timers.target. So this file is ready. I'm just going to write and quit that. And then I want to enable that timer. So I'm going to run sudo systemctl enable cert renew.timer. Now, with a timer and service file created, I should never need to manually update my certificate. That should all automatically happen in the background, and I should never have to look at that again. Now I'm ready to configure DNSproxy. So to kick that process off, I'm going to have to go to my browser. Now I'm on the latest release page of DNSproxy on GitHub. And here you want to find the tar file that matches your operating system and system architecture. So I've got a Linux system that's AMD 64. You'll want to copy this link address. We'll switch back to the terminal and we're going to want to download that file. So I'll use wget, I'll paste in that target, and just like that, we've downloaded that tar file. So we're going to have to uncompress that file. To do that, I'll run tar xvf DNSproxy, and you can see that created a new directory called Linux AMD 64. I'm just going to move into that directory. And in here, we've got our DNSproxy binary file. Looks like the executable permissions are already set. So just like my shell script, I want to move this to the user local binary directory. So I'm just going to run sudo move DNSproxy to user local bin. So once again, that's going to put that in the path, which is great. And you don't have to do this, but I like to keep the files in that directory owned by root. So I'm going to change the ownership to root. So if you're looking at the README file from the DNSproxy GitHub page, at this point you can run DNSproxy, enter in all your configurations right from the command line and start it up. But I find that rather tedious and I don't want to do it. So I'm going to set a config file for DNSproxy and I'm going to put that under the etc directory. So I'm going to run sudo mkdir, if I can type, and I'm going to call this one DNSproxy just to keep it nice and creative. And in this directory, I'm going to create a config file that DNSproxy is going to use for startup. So I'll run, sudo vim etc DNSproxy, and in here it's called config.yaml. Now before I started recording, I did create a config file, so I'm just going to paste that in here. A few things of note. It's going to be listening on port 8053 for traditional TLS. If I didn't set this, it would try and use port 53 and it would be conflicting with Pi-hole. I tried to figure out a way to get DNSproxy to not listen for traditional DNS, but I could not get it to stop. So I just planted it in a high port range. When you set up your firewall rules on this system, you don't have to open this port. I've also set the upstream to listen on localhost port 53. So this will reach out to the Pi-hole server. The TLS cert and TLS key, these are very important. You're going to want to change the domain here to whatever you used with the Lego command earlier, because you want this to match the cert and key that you grabbed from Let's Encrypt. Everything on the left side here, var snap lego common.lego certificates. This is the path that Lego command stuck your cert and key. So you shouldn't have to change anything on this side, but you'll want to make sure that the cert and key match what you have. I've opened up port 853 for TLS connections. That's the standard port for it. And port 443 for DNS over HTTPS. So this config file has all the settings that I want in it. So I will write and quit. Now I'm going to get into a little bit more of a deep dive on the Linuxy stuff. I want DNSproxy to run, but I don't want it to run under the root user. So I'm going to create a new system user that DNSproxy is going to run under. That's what this command is going to do. It's going to create a new system user that has no shell login, and I'm calling it DNSproxy. Now this DNSproxy user doesn't have access to the TLS certificate and TLS key that we declared in our configuration file. So we're going to have to give it permissions to access that. Now to make all of this a little bit easier, I'm going to actually just switch to the root user. And then I'm going to change directories to that Lego common directory. And in this common directory, I'm going to run this change ownership command, which is going to give the DNSproxy group access to the certificate and key that we've declared in the DNSproxy configuration file. Okay, I'm going to try that again with all my typos fixed, hopefully. Okay, that looks better. So now that I've changed ownership so that DNSproxy group has partial ownership, we'll say, of all of these directories and files, they still don't have the permissions for it. So that's what this command is going to do. It's going to give execute permissions to these two directories. And now I just want to make sure that it has read permissions of the certificate and key. So I'm just going to list .lego certificates, and then I'll do the command I actually wanted. So here the certificate and key are owned by the DNSproxy group, but that group does not have read access, so I'm going to have to change that. So this command here, chmod 640, is going to preserve the read and write permissives for root, and also add only read privileges for the cert and key, as you can see here. Read for the group, read, write for the owner. Now that all our permissions are set appropriately, I'm ready to create a service file that's going to start DNSproxy automatically. Because I don't know about you, but I love automation and I don't want to have to manually start DNSproxy every time I want to use it. So I'm going to exit out of the root user, and just like I did with the TLS certificate renewal automation, I want to create a new service file. And that's what this command is going to do. It's going to create a DNSproxy service file. Once again, I've created this beforehand, so I'm just going to copy and paste. So this service file is pretty similar to the one that we created before. I've got my description. I want it to start after the network is started. It's going to use that DNS binary that we just downloaded, and I've pointed it to that config file so that it uses that config file. And a couple of new things in here are the user and group that I've declared to be DNSproxy. What these two lines are going to do is make sure that this binary is running under the DNSproxy user. I've got a restart policy of always, just to make sure that it's always running. And once again, I'm not really going to get into what the target does. Just make sure that it is showing this multi-user.target. And with that, I will write and quit. And I should be able to start the DNSproxy service now. Right, I missed a step. Because the DNS proxy program is trying to use what's called a privileged port, we have to give it access to that. And we can do that with this command right here. I'm not really going to get into exactly what this does. If you really want to know, leave a comment down below and I will point you to some resources that will explain it. Just know that you need to run this for DNSproxy to have access to port 443 and port 853. Okay, now that I've fixed my mistake, I'm going to try starting DNSproxy again. And we'll take a look at the status. Perfect. Looks like it's running as intended. Now that we've got the DNSproxy service running, we've got Pi-hole running, and we've got Unbound running, we're done with the command line. There is still one more setting that you're going to have to do on Pi-hole before you can truly use this as your DNS server. So I'm just going to sign in using my super secure password. Under your settings, you want to go to local DNS records, and in here you want to create a record for this DNS server. Point it to the same IP that it's using and add that. Why you'll want this is it will allow the Pi-hole to act as the bootstrap server for itself. You're going to want this because if you've got a device in your network that's trying to access this domain for DNS, it's going to need to be able to resolve this domain before it can start using the encrypted DNS. Now, with all of that done, I can do some testing. Alright, for testing, I'm going to do a packet capture on that Pi-hole VM that I just created. This is just straight off of Proxmox's virtual network device that is on this VM 500. So I started the packet capture and I've switched over to a testing VM. On here I've installed a DNS querying tool called Q, and I'll run a few DNS requests with it. So I will start with using the quick protocol, and I'm querying where google.com is. And it looks like that worked nice and quick. Then I'll query youtube.com using the DNS over HTTPS protocol, and it looks like that worked. Then I'll query hardwoodhomelab.com using the TLS protocol. That worked. This one's going to query reddit.com on port 53 unencrypted. This one's going to query bluesky.app directly on port 53 just using the IP address. And just so you can see what a failed query looks like, I'm searching failed.com using the HTTPS protocol using just the IP. And here, since it can't verify the certificate, it fails. Now, I'm pretty new to Wireshark, so please forgive me if I'm doing things weird. But if I look for a string that is the query that I looked up, I should be able to find it. So my first query was Google. So we'll look for anything that says Google on it. So Google's coming up with both the Reddit and Blue Sky queries, which were both plain text. Looks like these are MX records, so I'm assuming both of these are using Google Mail. Alright, my second request was YouTube, and we can't find any string that has YouTube in it. I searched for Hardwood Home Lab. No packets contain that string. And of course we saw the Blue Sky and Reddit ones already. But yeah, Reddit is showing up in plain text and Blue Sky is showing up in plain text. So digging into the packet capture, we can see that our DNS queries have been end-to-end encrypted. To walk you through the Docker installation, the starting point is basically the exact same as the Debian install, with the exception of I went ahead and installed Docker first. My preferred method of using Docker is to use Docker Compose files, so that's what I'm going to do for this as well. The first thing I'm going to do is create a directory for Lego. I'm going to cd into that, and then I'll create a Docker Compose file with vim compose.yaml, and in here I'm just going to paste the contents of a compose file I created earlier. So I've created a volume within my home directory that's going to hold the certificates, and you'll have to change your Cloudflare email, your API token, your Let's Encrypt email, your domain that you're requesting, and your domain zone, just the same as I did on the Debian install. So I'm going to update these details, I'm going to save the file, and when I'm done that, I will carry on. Now with a compose file created, we can grab a certificate by running docker compose up. All right, so that grabbed a certificate. Now if I list my home directory, it should show me a cert directory, and it is there. So that is perfect, that's what we wanted. Now I'm going to make a directory that's going to run the rest of my DNS services. So I'm going to make this one, we'll just call this one DNS. I'll cd into the DNS directory, and I'll create another Docker Compose file. So I've created this Docker Compose file ahead of time, and I've just pasted the contents in. What it's going to do is grab the DNSproxy image. It's going to open ports 443 and 853 on the host. It's going to grab that certificate folder that I created in the last step, and it's going to save a config within this directory. It's also going to download the Pi-hole container. It's going to open up port 80 for the web UI and port 53 for local DNS. You'll want to change the time zone to whatever you want for you. I've got the password set here. If you don't set it here, it's going to create a random password and you're going to have a hard time getting into the web UI. I've set the upstream to unbound, which is this image right here. And this will create a volume within this directory that saves the config file. And then lastly, Unbound is going to act the same as the Debian install, although the configuration is going to be a little bit different. With that, I'm going to write and quit. Unbound is going to expect all the config files to be in place. So I'm going to make a directory for it. So this is just going to create a couple of files within that directory. And then I'm going to have to create a forward records configuration file, which is going to tell Unbound to use TLS to connect to the Quad 9 servers. So in this file, I'm just going to paste these lines. And these are basically the exact same ones that I used on the Debian install at the bottom of the Pi-hole config. The only thing that's different is I'm not declaring the TLS certificates. And that's because that's already declared in the Unbound configuration file that comes with this image. So I'm just going to write and quit. All right, so now I'm going to start up that stack. Running docker compose up -d. I'm going to do that with sudo. Sorry, I must not have had enough coffee this morning because I forgot to do the config file for DNSproxy. So I've gone into the DNSproxy directory that was created by the Docker Compose file. It had also created a directory called config.yaml, and I've removed that. So let's replace that with an actual file. config.yaml. So I've pasted my config file in here. It's pretty much the same as the install on Debian. The only difference is I've still got the listening port on 53. It's not exposed, so that doesn't really matter. On the upstream, it's going to talk to the Pi-hole container through the Docker network, so there won't be any traffic leaving the host. And then the certs. I've moved the bind mount to the root cert directory, so that is the only thing that's different. I'll move up a directory and we'll try running this again with sudo. Hey, I remembered it this time. So I'll give this a docker ps, and that shows all 3 of our containers up and running, so we can start testing this. So once again, I had to go to the web UI and create a local domain that points back to itself. And now I'm doing a packet capture on this Docker install. And I'll do the same tests as before, only this time I won't use Google. So this time I'm going to run an Amazon query using the Quick protocol. I'll do a YouTube query again on the HTTPS protocol. I'll do a Hardwood Home Lab query using the TLS protocol. Once again, Reddit using standard DNS. Blue Sky using standard DNS with the IP. And then another one for fail.com using TLS, just to show that it needs that certificate. I've loaded that PCAP file into Wireshark. Once again, I'm new to Wireshark, so if I'm doing something wrong, please let me know in the comments down below. But I'm going to search for that string again. I started with Amazon this time. And there are no packets. We cannot find Amazon anywhere. I think the second one I did was YouTube. No packets with that. Hardwood Home Lab. No packets. Now this is where I started using standard DNS. I went to Reddit. Standard query right here. For a standard query for reddit.com. Blue Sky. That one shows up in plain text because that's just on port 53 unencrypted. And fail, no packets. It was using TLS, but the DNS request was failed. So now that I've shown you that the end-to-end encryption is working, I'll show you what is being broken by this. If we take a look at our recent queries, you'll see that the Blue Sky app is from 192.168.240.165. This is that testing VM that I was using, and this is actually its IP address. But if I go back to the earlier requests, you'll see that my query for Amazon was from 172.19.0.4. That's not on my subnet. The Amazon one, same IP. That's also not on my subnet. Every query that comes through the encrypted line is going to show up as from the same user. So when you're using the encrypted DNS, you lose one of my favorite abilities of Pi-hole, and that is per client rule sets or per group rule sets. So if that's important to you, then you'll want to restrict who has access to the encrypted DNS. But outside of that, if you're going to be exposing your DNS server to the public internet so that you can have your ad blocking away from home without having to use a VPN, this is a great way to do it. So now that I've shown you 2 ways to install Pi-hole with end-to-end encryption, let me know if this is something you're going to use. I hope you found this informative, if not entertaining. But in the meantime, my name is Kyle, this is Hardwood Home Lab, and I'll see you in the next one.